Okay, we are going to do this practice problem using the subtraction method of the centroid, complex centroid unit. So first thing we're going to do is we're going to take this big shape and create one large simple centroid out of it. And since I have what looks like to be a square or rectangle, I'm going to create my square or rectangle by drawing my lines to create my triangle and my semicircle. So I'm going to call the big square shape, shape 1. My semicircle is going to be shape 2, and my triangle is going to be shape 3. After that, I need to look to where my reference axis is going to be. So my y is going to be over here, and the x is going to be over here, leaving my origin at the lower left-hand corner of the shape. Next, I need to find the area of all of the shapes. So to find the area of shape 1, so shape 1, I'm going to find the area. Since it's a square or a rectangle, I'm going to use base times height. So the base of this shape, we weren't given the total base, so we need to figure it out. So we know up at the top here, the entire width of the shape, we go 0.5 inches, plus the radius of this is 1 inch, so that tells me the diameter, the whole width, is 2 times that. So I've got 0.5 plus 2 plus 0.75 gives me my total base, or the total width of this, is 3.25. Multiplied by the total height of this, which was provided to me, is 3.75. So if I multiply those two numbers together, I get 12.188. And that's my area for shape 1. Okay, then I'm looking at the area of shape 2, which is a semicircle. And the equation we use to find the area of a semicircle is pi r squared divided by 2. So if I plug in pi times my radius is 1 squared divided by 2, and I calculate that, I get 1.571. Now, as I write this up here, 1.571, I'm going to make this area negative because it's not part of the original shape that I have drawn here in purple. I added it in. So at the end, we need to make sure that we subtract that area that we found. Then shape 3, I need to find the area. And since it's a triangle, the equation is base times height divided by 2. So we already found the base, oh, forget that. The base of the triangle is going to be 0.75 plus 2, so 2.75. And the height of the triangle, so we know the total height is 3.75. We lose 0.75 of an inch here, so I know the total height of my triangle is 3. So 2.75 times 3 divided by 2, that gives me 4.125. And again, this triangle isn't part of my original purple shape, so I'm going to make that a negative 4.125. Next, we're going to solve for the x-bar locations of our shapes. So for shape 1, since it is a square, to find the x-bar, I'm going to do the base divided by 2. So the base of this square, we know, we figured it out, it's 3.25. And if we divide that by 2, I get 1.625. So I'm going to put that in my box, 1.625. Then to find my x-bar of my semicircle, I know the x-bar is equal to the radius. So the radius of this is 1. So I go from the center point over 1. That gets me to the edge of the semicircle, but I need to get to the reference axis. So I'm going to take 1 plus 0.5 and get my x-bar is Then I'm going to calculate the x bar of my triangle. So to find the x bar of a triangle, I take the base and divide by 3. So I know the base of my triangle is 2.75 divided by 3 gives me my answer of 0.917. Now that tells me I come over from the right angle of the triangle 0.917 inches. So that's about right here. I need to know the distance from here to the origin. So if I know the overall distance of the base of this triangle is 3.25, and I subtract the 0.917 that I just calculated, I can find the distance from the origin, which is 2.333. And I put that into my box. Okay, then I am going to switch colors so it's not so confusing. So I'm going to go to green to find my y bar locations. So the y bar location of shape 1, I'm going to use y equals my height divided by 2. So the height of this we know is 3.75 divided by 2 gives me my y bar location of 1.875. Then I'm going to go to shape 2 to get my y bar location. This is where we use the equation y bar equals 4r over 3 pi. If I plug in my 1 for my r value, so if I do 4 times 1 equals divided by 3 pi, I get my y location of 0.424. So that means from the edge of the circle, I come into it 0.424. I need to know the distance from that point to the origin, so to the reference axis. So I need to take my overall height, 3.75, subtract it from my 0.425, and when I do that, I get an answer of 3.326 as my distance from this point I calculated to the reference axis. So then I'm going to find shape 3. My y bar location of a triangle is going to be the y bar equals the height divided by 3. So the height of this we determined was 3 inches. 3 divided by 3 equals 1. So that means 1 inch up from the right angle of the triangle down is 1 inch. And since it touches the reference axis, we know we're good. So now I'm going to switch to another color. Blue is good for multiplying. We're going to multiply the A column times the X column to get our AX column. So if we multiply 12.188 times 1.625, I'm going to get 19.806. Multiplying negative 1.571 times 1.5 gives me a negative 2.357. And multiplying negative 4.125 times 2.333, I get a negative 9.624. And then multiplying some more to get the YA column, I'm going to multiply A times Y. So if I do shape 1, 12.188 times 1.875, I'm going to get 22.853. For shape 2, I'm going to multiply negative 1.571 times 3.326, and I get negative 5.225. And for shape 3, I multiply negative 4.125 times 1, and I get negative 4.125. For my next step, I need to add together all of my columns that contain an area. So everything that has an area, I'm going to add. So if I add up 12.188 plus negative 1.571 plus negative 4.125, I get a total area of 6.492. I don't need to add up the X and Y columns because they don't have an area, so adding the XA column, 19.806 minus 2.357 minus 9.624, I get a total of 7.825. And adding up our YA column, 22.853 minus 5.225 minus 4.125, I get 13.503. Now that I have done that, I'm going to go back to green. It seems like I've got a lot of blue and orange on here. So now that I've done that, I can use my equations to find the X and Y bar of a complex centroid. So the equation we use to find the X bar of a complex centroid is X bar equals sigma XA divided by sigma A. So I'm going to look at the sigma column and the sigma row and the XA column, and the number that is there is the number I'm going to put into my equation. And then for the denominator, I'm going to use the sigma row and the area column, and that's going to be the number I use for my denominator. So if I divide 7.825 divided by 6.492, I get my X bar location of 1.205. Then I'm going to find my Y bar location by using the equation sigma YA over sigma A. So sigma row, YA column, 13.503 divided by sigma A column, 6.492. I divide those and I get 2.080. So that means when I go to locate my centroid location, I'm going to go over on the x-axis 1.25 inches. So that's about here. And I go up 2.08 inches. So that's about here. So my centroid location is going to be right where I did all that math. Right there.